Today on the Random Junk Channel, we're going to be seeing on, well, we're going to be testing to see if this will work, I guess is the easiest way to say it, how we can restore the sound to our pieces that lost the sound chip or the blob chip is cracked. If you watch the Octo Swing rebuild, the 4-parter, I use this style kit. It runs off of a 3.7 volt battery. But if you try and hook up to the 4.5 volt pads on here, there's no circuitry, so it doesn't work. Somebody suggested using a resistor. Well, a resistor works great for certain things. This circuit board doesn't like a resistor, hence the reason I have a new one. It's brand new, still sealed. And we're going to see if we can use what's called a voltage regulator to regulate the voltage at about 3.7. From a 4.5 volt power supply. And if it works, I'll be using this on a piece I'm working on right now that somebody, apparently, that's the way it looks, the person that owns it didn't do it, put the wrong power supply in and fried everything. The lights work and one motor just turns. It's supposed to go back and forth. It doesn't even reverse. But the big thing is the sound. It's a pirate ship and it needs sound. But a lot of them have blob chips that are cracking, probably because we had a hotter than normal summer in different spots of the country, and blob chips are susceptible to heat. The coating they put on top of it cracks, and once it cracks, you get moisture inside, and then it usually fails. The first thing that fails, which is the most common, is the sound and the micro switch, if it has any, in the part, or the piece, are the first two things that fail, and they fail equally. So first thing we're going to do, we're going to open this thing up, and we're going to remove this. I have looked at a few other sound file folder thingies, what you want to call them, MP3 players. None of them have, well, the price point. None of them have a good price point like this does. This is like 12 bucks or 10 bucks, and I bought a handful of them because I know there's a way to make these work. Also, these use the same speaker as Lemax. Whether it's this style or the bigger, deeper, more range, mid-range speaker, it's the same power. So you could technically just take this circuit board and put it into your piece and solder directly to the existing speaker, or swap it out for this speaker if you want one that's slightly newer. But this piece requires you to send to charge it. You need to use 5 volts. But when this is plugged in 5 volts, this will not turn on. And that's a problem. So I'm going to turn this on. So it's on now. And if I press the button, this is all pre-recorded. This is what it comes with. I haven't changed it. If I press the button again. And I'll press it one more time. Press it again, it should go back. And that's how you rotate through them. We got the volume switch. It's at I don't know, 85-90% off on switch. Your incoming USB micro, yeah, for charging, and then your connection here for your button, your connection here for your speaker, and your connection here for your battery. And they always come charged, because if you deplete these batteries, they become more explosive, and if you overcharge the batteries, they become explosive. So, well, they just explode. So this is a voltage regulator. This is an LM317. Voltage regulators come in different sizes and different numbers. At least that's what the part on the package says, and the bottom says LM317. So how this works is it takes a certain input voltage. You use a trim pot and you can control the output voltage. They're very basic. It uses a voltage regulator chip or component. They usually get really hot, hence the reason it's got a heat sink. So if you're going to put this in your house, you got to make sure this isn't going to touch anything else, and that you have clearance for it. Because, again, this gets really hot, and it's not an exaggeration. I have worked with these on other projects where I didn't put a heat sink on them, and they will start smoking within 30 seconds of giving them power. They get super hot really fast, which is why most of them are attached to a heat sink right there. You can put a bigger heatsink on here if you wanted to. Maybe put a full-size aluminum plate in the bottom of your piece and then screw it to it, so on and so forth. But you need to make sure it's heat sunk, and you should use thermal paste to transfer the heat from this to your heatsink. If you modify it, a lot of these sometimes use that thermal mat, which isn't as efficient. The paste is much better, and it's really cheap on Amazon. So on the bottom, it says ground, voltage out, ground, voltage in. So ground would be negative. Sometimes you'll hear me say hot and not, negative and positive, and that's just meaning the hot is the voltage in, positive, and the ground, or negative, or not, or earth is your opposite polarity. So I am going to use a little screwdriver here, and we're going to stick power to the input. So negative, positive, and I'm going to set this for 4.5 volts, and I'm going to show you with the voltmeter. And we're going to see if this works. And if this works, we have a viable option for salvaging our sound pieces. Now, to transfer files to this, you also have to use the USB port. So you need to put the files onto your computer. You cannot do it from your phone. Maybe you can. I wasn't able to. Maybe somebody out there smarter than me and can figure it out. I'm sure there's a way, but I was unsuccessful. So I did record the files on my phone, and then I transfer them to my computer, and then in turn I transfer them to my to this. And what's nice about this is the instructions. They're very clear, and they give you links. If you didn't watch the other video where I tried to use one of these. So it gives you online audio converter and an MP3 louder. Because when I did the other one, where I tried to make it work for the Octoswing, even though I converted the file, which this works great, I had to make it like 100 decibels louder, because when it transferred, it made it so quiet that this on full volume, you couldn't hear it. So it is really nice, and it tells you how to use it if you're a Mac user, if you're a Windows user. It has problem questions. Surprisingly, this is very simplistic, and it works decently, and that's why I bought a stack of them. And I literally bought a stack of them, because I might be able to use these in stuff I'm doing. You don't even have to use it for your village pieces. You can use it for if you're just building your own vignette. You're making it a lot of foam and wood and stuff, and you need to, have a spooky soundtrack. Bam, there you go. Because this thing can hold several minutes of sounds. It can be one long file or broken up, and that's why it comes with that 3-file test that comes with it. You heard how long the first one was in relationship to the other two, and if you plug this into your computer, it has those 3 files only take up like 8 or 10% of the space. I literally put a couple of minutes on here, depending on how big or how high quality your MP3 is that you convert or use. So let's get this started. So we're going to set this for 4.5 volts, and hopefully you can see the meter. I need a slight angle so I can see the meter. And we'll use this. Negative and positive. My machine says 4.7 because I just smacked the knob. 4.7 going in. And coming out, we're at 3.5. we need to be right around 3.7. So we need to pump up the volume, or in this case, pump up the voltage. So it's a little blade. It's already getting warm. I can smell it. So 3.5. Going the wrong way. It's going down. Almost there. So 3.7 round figures. Which is the same voltage as a battery. Alright. Now we're going to turn that off. And now we're going to put some wires on here from this to here, and we're going to take this battery out, and we're going to see if that works. So we're going to first is we're going to lift the speaker wires up. Now be careful. Again, lithium-ion batteries don't like to be shorted out, and that's why there's glue over those solder joints. So you don't want to solder and pop them bad boys and then have them touch each other. You might have a little bit of a bomb in the making. So what I do is snippy snip. So I'm going to snip the positive, and I'm going to move it out of the way, and then I'll snip the negative. You can remove the battery. It's just held on with double back tape. Just do it carefully. You don't want to fold or puncture the battery. So, and the extra precaution, if I'm going to store this, I'm going to tape the hot with electrical tape so it doesn't touch anything. But for the moment, they're not up close, so I'm going to set it out to the side and get it out of the way. So I got my soldering iron heating up, and I'm going to go ahead and remove this glue so I can use the existing solder pads, because they use the glue as an insulator as well as a isolator to insulate them from touching anything else and to isolate them from each other. Or else you could have a bang on your hands, and that would be bad. So, you know what? I think I have a small piece of red and black sitting over here. It's smallish. We're going to desolder these two pads just to make it a little easier. I'm going to put a little flux on them just for some better heat transfer. Soldering iron. And we're going to remove the two remnants before we solder on the new wires. One. Two. And this end, the wires are shorter from stripping them. So I'm going to use the shorter wires on board. So first thing is I'm going to tin these like that. And this says 3.7 and ground. 3.7 is closest to me, ground's in the middle. 4.5 is on the bottom, which is the one that doesn't have any circuitry hooked up to it, which is sad. and I don't have the time to sit there and try and figure out what is supposed to be there. And I haven't seen any from this company that are at 4.5 volts, because then you could just wire it right into your existing incoming power. You know. There we go. Now, so I'm looking at the bottom so I know which is which. So you can technically tin these before you shove them in. A lot of the electronics come from like China or that way. Because what that does is it stops the wires from fraying when you stick it in, and causing an issue with a straggler like I just had. So I'll probably just tin them real fast. Turn off the soldering iron. I gotta wait a minute here or a few seconds for this thing to get back up to temperature. There we go. Now, technically, if you're so inclined, you could remove these blocks and just solder your wires to them directly, or solder them on the bottom. I'm not going to do that, and the reason I'm not going to do that, well, one, this isn't going in a piece, but if it was, is that way if it ever burns out, because again, this gets warm, and heat is a bad thing to electronics, you can just unscrew it and replace it. You don't have to whip out a tool like a soldering iron. All you need to do is a small screwdriver and you're good to go. So we're good. It's all hooked up. 4.5 in, 3.7 out. We'll double check it with the voltmeter. So if all goes well, we should have the ability to use this now. And then I'm going to might as well get it out right this moment. Let's see how hot that's going to get, so you have a basic idea. I don't know. I'm going to say it's probably going to reach close to 200 degrees. Depending on how long it's running, I guess, would be the big thing. The longer it runs, the hotter it'll technically get. .725, and that's because I smacked this and it bumped it up another little bit, so that's why that went from 3.701. So on. Right now, that's running at about 76 degrees Fahrenheit, the back of the heat sink. Still running at 76. Let's see if I can carefully turn this thing around. Turn the power off to it just to be safe. so I can see the front of this. I know the heat sink's doing the majority of the work and it's doing what it's designed to do, but let's see if the face of the chip actually starts to get warm. Power on. I got 4.8 volts going in, which compensates for that free float that you get on the Lemax adapters, because I'll go up to 5 on average. We're at 77 degrees. $77.4, 5. I know there's a hold button on here somewhere. So that's what it's at right now. 77 degrees Fahrenheit. That's the F right there. And the battery is at 200 milliamp hour. And watching my machine, we'll do it again. And I'm going to crank the volume, so it's going to get really loud. If you have headphones, I am sorry. But the maximum volume is going to be the maximum pull of the unit. So not only am I going to hate this, if you're using anything like amplified speakers, you're going to hate this. So, noise warning. Maximum volume. I'm going to watch the voltage. Because again, this battery is only rated for 200 milliamp hours, so this board should be way less than that. Hopefully. Because I really don't know what this thing's rated for. Because it's all in Chinese. I don't know why it's clipping. $79.2 is the hottest. This is pulling less than 200 milliamps, but it's clipping, meaning it's resetting. So at its peak, it was pulling 150 milliamps on that yodel. Now we'll go. On that one, it pulled at its peak 170 milliamps, so that's a lot closer to the battery's max, because I think this might be clipping, or the button's going out, one of the two. And that one maxed out at 140 milliamps. Power consumption is very important because if you're going to put this in your house, you're going to have to solder this on the incoming power of your unit. You got to remember, whatever the house is rated for, you got to take into, I know the circuitry is bad, so there may not be any power in that part of the circuit, but you got to make sure that this plus the house's power is within the 1000 milliamp hour rated head. That's what I use. They do come as low as 600, so you got to be careful. And this thing is pulling at full volume. The max has been 170. And the chip at the moment is, where's the chip inside the little radar thingy? Try and hold it once I get it lined up. It's cooling down. 77.9. It was at 78. Yeah, she's not warm yet. I think the switch is my problem. It is heating up, but not by much. So the next step would be to record a soundtrack from a house. Where's my other one? The one that didn't work. There it is. So let's kill the power. So here's the one I tried to use in the Octo Swing, which has the Octo Swing recorded in it. And this is the bigger speaker I was telling you about if you watch Octo Swing. This is still 8 ohms, half watt. It's the higher quality speaker. It's more of a mid-range speaker. And these are more like tweeters or high-end. They're just cheap speakers. So let's desolder from that board. Solder on this board because this has the Octo Swing's soundtrack. And we'll go from normal volume to max volume and see if it spikes higher than 170 milliamps and if this adjusts in temperature. To be honest, I didn't think I'd be doing this video for half an hour. But this could be a viable option for doing your own custom sounds and replacing your sounds on your piece if and when they burn out. It's not up to temperature yet. Now it is. Okay. Not too often we have cop cars screaming down the road. Apparently they weren't looking for me because they didn't stop. I don't know if you could hear the police, but they just drove down the street next to mine. Unfortunately, it's not a joke when I said that they're not looking for me, because when I did custom cars in my driveway, the neighbors would call the cops on me, just 2 of them, for doing custom cars in the driveway. I got visited quite often because they have to come out and investigate, and then they find out that it's not against the law or against code to build a car in your own driveway. It's kind of weird, but that's how it is. Alrighty. Power's on. Oh. Yeah, we're clipping. So let's try a lower volume. Oh, something happened. We just lost everything. Oh, we got power in. We lost our power out. It dropped. Make sure nothing's touching. Do the good old sniff test. Smells okay. Temperature was in the 80s just before it turned off, which is nowhere even close to an LM317T chip. Wires were still good. They're still in there snug. All right. Now, why did we lose it? So, hot. Not. Now we're back to 3.7. That's why it's clipping. It's dropping below its threshold for the board. Okay. I'm going to turn that off. I'm going to bump this up just a little bit. You got to remember, everything in electronics, well, not everything, but most things have a 10% plus or minus on tolerances. Some are 1%, some are 0.5%. But for the most part, 10% is pretty common. So I'm going to bump this thing up just a little. This circuit board technically should be able to handle up to a little over 4 volts. So let's bump this up closer to that 4 volt threshold and see if we still get the clipping. Because the octo swing runs a lot higher pitch, meaning the higher the pitch, the more power it's going to draw. That's when it would spike to the 1.7 or 1.5 or 150 milli amps or 170 milliamps. Basically what it was doing was the higher the pitch, the more power it takes. So, alright, so let's get that in. 3.73. And maybe I can, if not, maybe I'll find another one of these that puts out a slightly higher or has a higher current rating. .78. 3.8. So now we're 1 volt over the battery's rating, but I'm sure the battery's higher than 3.7. 3.81. This is a very fine screw, meaning it doesn't adjust fast. Also, at the angle I'm at, I keep slipping off of the screw. .84. Let's just adjust the screw without my other hand in the way. .386. See if we can get it around 3.9. .387. Wow. close. Maybe one more turn, we should be right around 3.9 volts. I don't know how much more is left on this screw before it maxes out. It might be maxed out already. And that's basically 3.9. There we go, 3.9. So I'm going to try and leave that right there. And we're going to turn this back on. Now I'm going to check the millivolts. So it spiked at 120 milliamps. I meant to say amps. I know I just said volts. And that's at about 50% volume. Again, if you have headphones, earbuds, amplified speakers, I'm now going to put this at full volume, which this at full volume is louder than that one. Because this, I increased the volume on the chip to compensate for the piece. And I'm using a higher quality speaker. Same ohmage, same wattage, just a better speaker, bigger magnet. So, full volume. Let's watch what this does on the screen, and I'm going to watch, try and watch between the two. I'm going to go back and forth between looking at that and looking at the power supply, where it tells me how much in milliamps it's pulling. Right now it's 0. So here we go. It's going to get loud. More loud for me than you, most likely. Can't do it. So let's turn it off so it resets. Let's turn the volume down. So it can't do it. This power is clipping because the threshold voltage is going too low. It only spiked at 6 thousandths of an amp. Milliamps is 0.1. That would be 100 milliamps. This is 0.06, so it didn't even get close to even 100 milliamps. So there is a threshold that the LM317 can take, and apparently the threshold is the voltage drop, the loss of power between what this draws and what it can put out. So this is drawing just a little more than this can keep up with at full volume. But at half volume, it played the whole thing. So we're back at half volume. Oh, I turned it off. Turn it off so it reset. So this technically could work, and the reason I say technically is if you don't run your house at full volume, like you set it at a volume and just leave the volume switch set, you can tell it played the full 20 or some odd second the thing all the way through, even though it dropped below technically its threshold, but there's still enough power to run the chips and make them do what they need to do. This isn't really getting hot. Where are we at now? We are at 78 degrees. So it's not, she's not getting warm. So using a LM317 voltage regulator that's already pre-built with the components, you might be able to get this to work. There might be a way to change the components on here. There's not much on here. You can see the bottom of the solder. We just have the incoming power, the chip. We have a variable potentiometer or a variable resistor, which that part number is, it's an M or a W103. And then we have a 50 volt 47 microfarad capacitor. So there's really, and then there's a little guy in between, which is, we got a resistor and another little capacitor right there. I can't read the capacitance. It's pretty basic. You can actually search online for circuits. The resistor is 221, I think is what it says. I think that's 220 ohms. And the capacitor, the little guy on the corner here, has no markings whatsoever, which is this one right here above my thumb. There's other voltage regulators out there. This is a voltage regulator. This is an LM2596. This one might work as well. I've been buying them to try. We tried anything to make the sound work. But this is used for charging those lithium batteries, these guys right here. That's what this is usually used for. It has an overcurrent stop, and it's a little bit more advanced circuit. You can tell it's brand new. You can see that this is way basic, but more advanced. It has, this one is the same W103 potentiometer or a variable resistor. We got a couple of coils, inductors, and it's DC to DC. So in, plus and minus, out, plus and minus. See, this one says in, plus and minus, where this one says ground and VIN for voltage in. And like I said, this one should just regulate incoming power. Let me look up the spec real quick. And this is the nice thing about our technology. You can just whip up the Google and type in, this is an LM2596. So if I type in LM2596 and click on the first one that says datasheet, it says it is a DC to DC buck adjustable step down power supply. Oops. Looking for the data sheet. There it is. So it's can take 4.5 volts to 40 volts, and it's 3 amps. So this one might work. Let's see. 12 volts in, 5 volts out. So voltage in is 4.5 to 40, and voltage out is 3.3 to 37. So why don't we give this one a whirl? We're here. We're already 45 minutes into this. Let's hook it up to this. This one, though, we can't just use these. They have to be soldered on. So we're going to do some soldering. So first thing I'm going to do is remove my tube. And I'm going to change this one from an Arduino connector to a piece of wire. Like so. These I bought because they specifically said that they're designed for charging lithium-ion batteries. And since I have random batteries like that, I thought I bought one piece. I bought a package of 12. So I got a lot of these little guys. So if these work, so this side's the in, away from that, then we'll use this. So this is the hot, and this is the not. I'm just going to do them from the bottom and solder them on the top. It's got solder pads on both sides, but I'm just going to solder them on the top. So to solder them on the top, I'm going to feed them in from the bottom. Ooh, I hear more sirens again. Something must have happened nearby. So there we go. Now I'm not going to solder anything on the output yet because I want to adjust this before we just plug it in and then possibly send 37 volts. Or we won't send that much to that. But you get my point. So, power that on. Let's make sure. Voltage in. Let's make sure those don't touch each other. And voltage out. That's the negative. That's the positive. Safety squints on. Power on. So I got 4.8 volts going into it. And I have 4.5 volts coming out of it. That spike may blow that board. That's why I didn't want to solder it on yet. So we're going to adjust this and see if that goes down. It appears to be going up. So let's go the other way. Doesn't matter which way I turn it, she's not moving. Well, now it's moving. Oh wow, this is going to take forever. Oh, it's even got a little idiot light. Look at that. I don't know if you can see that on the camera, but there's a little glowing idiot light telling me there's output power. Huh. Cool. So busy looking at the voltmeter that I'm not paying attention to the circuit board. I'm trying to get this below 4. I don't think I just dropped it that far. I think I disconnected from the pads. Maybe I did. It says it's not supposed to drop below 3.5. Is that 3.8? .83. That's good. Let's turn off the power, solder these wires on, see how this works, see if we get a voltage drop or a spike. And then we'll... Now this chip is the same as that chip as far as the function, not the same chip. And the heatsink is directly underneath it, soldered to the board. There's a sharp spot on the board. Probably when they made them and they broke them, there's a little splinter. Anyhow, so the heat sink's underneath. It's right there. Not as efficient as that one. I don't think these will... going to do the same thing. I'm going to go from underneath, but the wires keep trying to pull out of their sockets. I'm going to do one at a time. I'm also going to solder them in properly, meaning I'm going to bring the solder to the unit and not solder from it, just so I can get it to stay. There we go. Right, so maybe these will work, and if these work, I have a dozen of them, but I only bought one of those. And then if you want to know where they got them from, I got these from Temu. I buy their circuit boards to test them, and so far, they've all worked. So, it's just the way it seems to work. Everybody thinks their stuff is garbage. I have had some lower quality products, but I haven't had any circuitry be lower quality, surprisingly. So 3.83. Another one. Oops. So it went to 110 milliamps, and you notice the voltage only dropped by, well, not even 1/100 of a volt. This one might work better. Now we're going to do it again, full volume, and try it. So again, if you have your headphones in and stuff, you might want to lower your volume and or disconnect them from your ears for the next 15-20 seconds. So here we go, deafening sound in 3, 2, 1. Alright, now I'm deaf, so I'm bouncing back and forth, looking here and looking here. I think this one is low as 3.4. I would have to watch the video to verify. So still technically within threshold. I know that's 3.7. Take 10% of 3.7. That would bring it down to 3.23 approximately. So 3.4 is within that 10% threshold. If it was any lower than that, I'll see it when I edit the video. The milliamps, though, spiked to 330 milliamps. That's probably why this is clipping, because it clips at a lower milliamp, and then I don't see it on the machine because this cuts it off. This volume at high, with this soundtrack at 3.8 and 4.8 in, was spiking at 330 right there when it gets really loud towards the end. The rest of it was running between 1.7 and 2.5, or excuse me, 170 to 250 milliamps. Apologize that I put the decimal point in there, but it's just an easy way to round stuff up. And that chip is at 80 degrees. So it's not much hotter than that one. Matter of fact, that one was almost 81 at its peak, probably because it was clipping and it was turning off and it was getting too hot. This would probably work good for LEDs, but technically a resistor would work too. You want something that has a voltage constraint, but not a high amperage draw. LEDs are usually low amperage. I would not use this for anything else than that. And we're testing this together. So this one is probably the better option. One, it's a lower profile by a lot. I'm trying to power off so I don't short anything out. So you can see the profile is much less. It is a bigger board, so if we put them on top of each other, since the power is off, you can see this board is longer. It's the same width. So, with this being a lower profile, it might fit better in your units, but being longer, it may not. But for the speaker volume, depending on how you have it set, whether it's max or min or somewhere in between. Looks like the LM 2596 DC to DC adjustable buck regulator will work the best. There is one other issue, and we're not putting this in a house. I'm doing this on a voltage meter, a voltage supply that's regulated on a bench with nothing else in the circuit. If you've seen or listened to most of my videos, when I talk about circuit boards, I always mention there's always like this big fat capacitor like this or something similar. Motors and animated houses are noisy, so there's a capacitor to quell the noise of the motor. If you were to graph it on a graphing multimeter like this one does, that's why it says graphical right here, you would see the spikes. It's not a smooth line, it spikes. Electric motors are noisy. Alternators, generators, they're noisy, meaning that they put noise into the circuit, not noise into your ears. So we use capacitors to smooth them. Now this doesn't have a smoothing capacitor on the input. It has there might be itty bitty one there, but that's not big enough to quell a motor. We got idiot light. See, these components aren't labeled. I'm assuming that's a capacitor, and that's a capacitor, but they're too small. They're itty bitty little pieces. The rest are inductors, and then there's a couple resistors and one diode. That's a dull yellow that lets you know that the you got output power because it's on the output leg. So it's just to give you a visual indicator that it's working, which is kind of nice. So you don't have to sit there with one of these, but you will need one of these to adjust it. And oh my God, you need to spin that screw. So the LM 2596. Hopefully you can see right there. Temu, and this is the LM 317. Temu. The reason is if you order the chip online, they send you that. That's the chip. That's the chip. Then you have to build the circuit. Well, on Temu, I think they're like $1.90 a piece. You may have to wait 3 or 4 weeks to get them, but you can get them in quantities. Like, no joke. I got several of them. Actually, that on the OctoSwing, if you watch the OctoSwing rebuild, the timing chip that tells it the reverse back and forth, that one came from Amazon, but I found them on Temu for about 1/8 the price. Now, I don't know if they're the same. I don't know if the quality is any better. I didn't buy any. I just buy random circuit boards from Temu to test them, because you never know. If they're garbage, they're garbage. I'm out a couple of dollars. If they work, they work, and I saved a couple dollars. So it's up to you if you want to try it, if you want to buy it. I'm going to probably install this in the piece I'm working on right now, the pirate ship that has a bad sound chip since the blob chip is split open from being overpowered. We'll make a custom lighting circuit for it. I've already started filming it. I stopped 20-30 minutes in when we realized at that point that the board is destroyed, that there's no signals going through the board. All the board is doing is sending basic power to the motor in the one spin position, and that it's also sending basic power to just half the LEDs. That the board isn't responding to anything because, well, once it was examined, the chip is cracked. So, not much we can do. But if we can get some sound working on it, and I can find a video online of the sound to do the recording and transfer it, at least I can make the lights work and the sound work. It won't have motion. 2 out of the 3 ain't bad. Considering now it's 0 out of the 3, or 0.5, since again, half the lights work. So it's all relative. It's all on how you look at it. You can look at it negatively and say, oh crap, it doesn't work, it's not working the way it's supposed to, it's garbage, so on and so forth. Or you can say, hey, it doesn't move, but I can get my lights back and get my sound back. It might not move around on my display, but heck, it makes noise and it lights up. So it's just on how you look at it. So at the moment, I'm leaning towards using this one, well, definitely, over that one. But this is why we wanted to do a test, and I mentioned in the video from the OctoSwing that I'm going to do a sit-down test with these pieces. That is why I ordered a whole bunch of these little guys. Well, here's the OEM one, not the one I modified. And I ordered different soundboards. or excuse me, different regulators, adjustable power supplies, since the 4.5 volt track again is not connected on this, which is a shame, because that would make life way easier. I wouldn't have to put something in between. Using a resistor doesn't work. Resistor is great for lights and certain things, but if you put a resistor in here, that resistor will turn into smoke, and the resistor, the other one, because like I said I bought several, the chip fried with a resistor. So, and the resistor got really, really hot. I probably wouldn't trust it anymore. That's why I threw it away. The resistor went from a dull resistor to a very shiny resistor because it was starting to melt. That's why sometimes you need regulators. They work pretty good. Transformers will do the same thing. That's what they do. They step up or step down your power. So there's a half a dozen things we could try. I'm trying to try something that will work, that's small, that will fit inside your house, that is viable, and that you can do at home. So you don't have to send it to somebody. Save you on shipping costs and the possibility of it arriving in like Humpty Dumpty, as I call it, where you can't put it back together again, because that just happened to me a couple of weeks ago when I sent a piece back and it arrived and more pieces than there's enough glue in a grocery store to put it back together again. But it's insured and the process has been done. So we're good. So you might see this coming up in a future video where I put this inside that pirate boat once I find the audio track, and hopefully this lasts a really long time and it works. I said, as far as I know, I haven't had any problems with Temu products as far as electronics goes. I bought a light switch from Temu that is warped from the travel time. So it's either because it's Arizona and it's hot as hell out here and it got hot in the postage, or it's from just going across the ocean. I'm looking at the components. They're name brand components, so technically they should work fine. Not everything has a name, but the ones that are visible, they're name brand. That one I can't read. They have the name facing in, of course. This one just says made in China. So that might be why I can't handle the power. And this is a 3-leg power adjustable voltage regulator, and that's a 5-leg. And it's actually got a real part number and a real manufacturer, and it actually says adjustable. And this one just says the part number, the LM317T, like Tom, and then it has a part number I can't read, and then it says made in CHN. So if you lost your sound, so the end result, let's go over the end result before we stop the video. Lost your sound, you want it to come back. Go online, record the sound, probably using your cell phone, or if you have some higher quality devices, use that, from a video or a soundtrack of that house, whatever it is you're trying to record. Then transfer it to your computer, if you're recording it from a different device than your computer itself. And then use the USB cable enclosed if you want, or use one that's longer. Transfer it onto here. This pops up as a file folder because it actually is listed as a hard drive. My computer reads this as a hard drive because it uses a like an EEPROM type chip. I forgot what it's called. The other guy that works with the RandomJChannel, he is more computer savvy on what the name of it was, but he told me and I don't remember, and I truthfully don't care because it shows up as a drive, so I can just transfer stuff in and out of it. I'm good. You can remove those 3 audio tracks and delete them or put them on your desktop or whatever you're going to do with them, and then download your own track into it. You can use the programs that come on the card to adjust the volume and do the conversion. Because my phone recorded it for this one, and it recorded it as an MP3. But, like I said, it was super quiet. So I went to m3p3louder.com and I had to increase it a huge, like 180 decibels, which is extreme, which is why this gets extremely loud. So that way it's audible, because when I transferred it on full volume, it was like a whisper. And then at that point, you're good to go. Now, if you have some fancy editing program, which I don't know. I don't use my computer for watching YouTube, paying bills, checking emails, and then dealing with the random junk channel stuff. That's about it. I have a very dull computer existence. You might have a program where you can loop it, like they do in the actual soundtrack. So if you can find out the maximum duration that you can put on here, let's say it's 3 minutes, and it's a 20-second file, that means for every minute you can loop it 3 times, which means you could loop it 9 times for a 3-minute file, which is what the Lemax pieces do. So if you could loop it, then you only have to press this button, which means you're going to have to install a button on your house, boat, carnival ride, whatever, somewhere conspicuous, or make it conspicuous. It's yours. You can do whatever you want. You only have to press the button once every 3 minutes. And most people that I know don't have their sound on unless people are looking at their stuff. And you're probably not going to stare at it for 3 minutes. That's a really long time to watch something that just repeats itself. Usually the house repeats itself every 20 or 30 seconds. The only downside that I can see, besides you have to do all this work, you have to buy, right now this is about $14 worth of stuff, is it may not match the lighting track. Now, if you have a piece that has thunder and lightning, the flashing LEDs, and so on and so forth, your audio won't match. So if it's talking, like a character gets lit up and they talk, and another character gets lit up and they talk, and then you hear the lightning bolt and the lights flash white, it's not going to match. You can try and time it, where you press this button right at the right time, and boom, everything lines up and syncs perfectly. Probably not going to happen. So that's a downside. At the moment, we're progressing towards replacing your sound and making it more usable and match up with what you got. But nothing's perfect, and Lemax doesn't sell their information or give it to you. Your other option is you can take the Lemax circuit board and you can literally replace everything on there to see if you can get it to recover, but you can't replace that blob chip. And that's the brains, that's the IC, that's the circuit that tells everything what to do. So if one of the discrete components is bad, like a capacitor, resistor, transistor, even the amplifier chip, which this has one too, it's right there, you can replace it. But if the blob chip is bad, like in this case, this big chip is the integrated circuit that remembers everything and also tells it what to do when you press the button. It also handles with charging, which is that guy there, comes off of here but goes to here, that's your charging one. It tells you, I believe that's the charging one, it's upside down, can't see it, but it tells it what to do. Yeah, that's your charging chip right there. So that's where we're at, and I might start using this in the future with that and that together. Maybe not that speaker. Maybe have to go back to that depending on the house again. And we should be good. So this is kind of a drawn out video. You get to see the process. You get to see what I'm using. You get to see what I've been buying. I've been trying to catch up on some of these bigger pieces that have lots wrong. I know a really recent video, I don't know if it'll be up at the time that this is put up. It's like 2 hours and change minutes long, I believe. Because it was really in depth. Everything was broken on it. It sheared itself. It was a carnival ride for Christmas. And those take time. The video itself is 2 hours approximately. But I spent like 17 on it. Trying to get it all figured out and working. I did some of it off camera. I did some research on it to see if there's anybody else that's had similar problems. I had to wait for parts to arrive. So I'm trying to catch up with a lot of these videos, but real recently, the ones that are coming in that I've been working on, they're not just like replace a motor, pop in a new gear, got a bad belt. We're talking burnt circuit boards that are caught fire. We're talking power supplies that were put in wrong and the blob chip split open, and now we have to recreate what Lemax did. We are talking massive endeavors that most people at that point would just throw it in the trash or Goodwill it or something of that nature. So videos will come out sporadically. Some of them be really long, like this one's an hour and 11 almost right now. and it's not intentional that they're long. I'm trying to be more in depth because I get a lot of questions like the short little 6-minute video of the Mad Pumpkin Patch. How do you replace the LED? Well, when I repaired the pumpkin patch, I didn't show you how to replace the LED because the LED wasn't burned out, but that would only added another 2 minutes to the video. So I'm trying to be more in depth so that way, if you have a problem, even if it's outside of what I'm repairing, you can see how to access it. But unfortunately, in the process of doing that, it extends the video's length. But you can always use the 2x speed, because that's how I watch videos, and you can skip. So, and you can go back and forth. And worst case is if you're just too lazy and you don't want to watch the whole thing, you can email me. I usually respond within a day or less, depending on if I'm at work or not. So at the moment, I'm going to say this setup at this time is probably the best option to replace sound, or make your own custom sound. Like I was saying earlier in the video, you want to have a spooky soundtrack instead of using the custom Lemax stuff, or like say you got the Symphony of Screams. It repeats the same stuff every 20 seconds. Maybe you just want it to turn on and play a symphony of scary music. So bypass the existing circuit by just cutting the speaker, and then do your own, stick this inside, so when it turns on, instead of it playing the same where the guy's talking and then you hear the music for 15-20 seconds and the guy talks again, it just plays Thriller, or it plays the Hitchcock theme song, or it just plays spooky music in general. I think that would be really cool because it doesn't have flashing lights that match the music. It just has flashing lights and then moving dancers. Don't need to hear the dude talking at the beginning. For an intro, great, but for it to repeat every 20-30 seconds, kind of annoying. And I like that piece a lot. I just don't like it with the audio on. So you could even modify your existing stuff to whatever you like. If there's something out there that has a longer memory that plays continuously, if I find something, I'll update the video. I'll make another one. But at the moment, I'll link this from Amazon below the video. I'll put this on there. I'll try and find a link on Amazon. I'll see if they're still on Temu, because Temu seems to constantly run out of stuff and then they restock it. And then if you don't want to be on their mailing list, because they'll email you 35 times a day, text messages, emails, you name it, it's going to come to you. They want to make sure you're still alive. So I'll put links if you want to try and do this at home, or if you just want to use it for something else, like I was saying, your own custom project. Also, Skull Crane Animatronics, they have a kit you can buy for your tall Jemmy characters that they will do a custom soundtrack for you. I bought one of their kits, like $30, and then they charge you like $20 to program it, so like $50-$60 altogether. And I had it do a soundtrack for Thunder and Lightning, because in my Lemax room I have a lightning and thunder generator, and for some reason the audio side burned out. It's been used like 10 times. So it's 4.5 volts. The audio generator that was in the room is 4.5 volts, so it all runs off of the same power supply that Lemax uses. And I lost my audio. So before I knew this stuff existed, I paid somebody else to do it. And then I just wired it into my room for the display. Now I can do it myself for a third the cost. So you got choices. If you have any suggestions, comments, concerns, questions, whatever, put them below. Email RandomJChannel@gmail.com. It's also linked below. You can Facebook message if you don't have email, which is pretty impossible these days. And yeah, I think we're good. So we got to start on salvaging our audio. So until the next video, if you watch this whole thing, thanks for watching, and I'll see you the next time.